Good afternoon, class. In Chapter 4, Application of Derivatives, Section 4.1, Maximum and Minimum Values, and he got through to finish off the topic of maximum and minimum values. I want to remind you, as far as the maximum and minimum value is concerned, if we have a continuous function and a closed interval, it gives rise to the extreme value or closed interval theorem, which means the function must have an absolute max as well as absolute mean. The methodology is to find the critical points by finding f prime equal to 0 and f prime does not exist. Then we evaluate the function at the end points a and b as well as the critical points. Absolute maximum is the largest value. Absolute minimum is the smallest value. So when you find the absolute max and minimum value of the function f in the given interval, where f of x is x over x squared plus 2, the interval of 0 to 4. Now, remember the function has to be continuous. By continuity, it means really what is the domain. So we want to discuss the domain for this function. Notice this is a rational function. A function f is a rational function if f of x is n of x over d of x. D of x, the denominator, can't be 0, where n of x and d of x are polynomials. The domain of f consists of all real numbers except the zeros of the denominator of f of x, namely d of x, meaning you set the denominator equal to 0 and exclude it. For example, for y equals 1 over x, let's say minus 2, you set x minus 2 equal to 0, x becomes 2, and you are going to exclude that. The way you exclude that, you can say x is not equal to 2. However, the best format would be the interval format, negative infinity to 2 union 2 to infinity. So you're excluding number 2 because you use parentheses. That's how you find the domain. In this case, you have to set the denominator x squared plus 2 equal to 0, and this doesn't give you any solution. As you know, phi represents an empty set. Why not? Because you have x to the power, which is an even, and you're adding some number to it. So x squared plus 2 equals 0 will never produce any solution. Although this is a rational function, the domain is all real numbers. So we are going to write f is a rational function, and it's continuous on negative to positive infinity. You can say the domain is negative to positive infinity, or is continuous from negative to positive infinity. And therefore, it's continuous in the given interval of 0, 4, because negative infinity to infinity contains the interval of 0 to 4. Therefore, we want to move with the process number 1. We want to find CPs by finding f prime of x first. To do so, we are going to write f over g, and we are going to use f prime g minus g prime f over g squared. That's the quotient rule. So f prime is simply 1 times the bottom x squared plus 2 minus g prime is simply 2x times the numerator x, and you write the bottom in a parentheses and square it. So x squared plus 2 quantity squared. Now we are going to do algebra to finish the job. We are going to write x squared plus 2 minus 2x squared. X squared and minus 2x squared, they add up to minus x squared. So here's f prime of x. F prime equals 0. A fraction is 0, as we mentioned before, when the numerator is 0, in this case, minus x squared plus 2. So if minus x squared plus 2 is 0, that means we move this and we get 2 equals x squared. X is plus minus square root of 2. F prime does not exist, that means the denominator is 0. As you know, when we worked on this one, x squared plus 2 equals 0, didn't give us any solution, x squared plus 2. When you raise it to any power, makes no difference. This doesn't produce any solution either. Therefore, we have two critical points. Which one is in the interval of 0 to 4? Is square root of 2 in between? Remember, square root of 2 is about 1.41. Yes. Is negative square root of 2 in between? No. So only one of them is acceptable, which means we are going to evaluate the original function at these two endpoints as well as this critical point. I'm going to erase my work. So we write the function. F of x is x over x squared plus 2, and we're going to start with 0. Obviously, when you plug in 0, you get 0 over 2, which is 0. We're going to plug in square root of 2. So the numerator is square root of 2. This is square root of 2 squared, which means 2 plus 2 is 4. So square root of 2 over 4. We plug in 4, we get 4 over 4 squared plus 2. 4 squared is 16 and 2 is 18. 4 over 18, which means 2 over 9. Now, you should recognize this one is larger than this one. If you don't, you can go with an approximation using decimals. You should easily see 4 almost times 2 is 9. So if you multiply this one by 2, you get 2 square root of 2, and square root of 2 is 1.4. 12, it is 2.8. So it's larger than in any event. So the absolute maximum is this at this pair, square root of 2, comma, square root of 2 over 4. And absolute minimum is 0 at 0, 0. This is how you do the writing, everybody. We are going to move on. We want to find the absolute max and mean for this function. F of x is x to the power of 4 minus 18x squared in the interval of -4 to 1. And the first thing is to discuss continuity or the domain of the function. As you can see, this is a polynomial of degree 4. There is no restriction. The domain is all real numbers. Therefore, it is also continuous in the given interval. So we write f is a polynomial of degree 4, is continuous on negative to positive infinity, and therefore is continuous over the interval of -4 to 1. So we are ready to move on with f prime of x. F prime of x is 4x cubed minus 36x. We are going to set this equal to 0. To do so, we are going to factor it first. So first and foremost, 4x is in common. 4x times x squared minus 9. X squared minus 9 is a squared minus b squared. So 4x times x plus 3x minus 3. We have factored it, so we set it ready for f prime equals 0. So f prime equals 0 will give us x equals 0, x equals -3, x equals +3. There are 3 answers. F prime doesn't exist, doesn't give us any solution. Phi in an empty set. Why is that? F prime itself is a polynomial. More specifically, a polynomial of degree 3, and it exists everywhere. Its domain is all real numbers. So we have 3 possibilities. Is 0 in between -4 and 1? Yes. How about -3? Yes. How about +3? No, it's outside. So only -3 and 0 are in between. And we are going to evaluate the original function at the 2 endpoints and the 2 critical points in between. We are going to put the function f of x equals x to the power of 4 minus 18x squared. We're going to plug in negative 4. Negative 4 to the power of 4 is positive 256. Negative 4 squared is positive 16 times negative 18 is negative 288. And they add up to negative 32. We're going to put negative 3 to the power of 4 minus 18 times negative 3 squared. This is positive 81, the exponent is even. This is positive 9 times negative 18 is negative 162, and the answer is negative 81. If I plug in 0, clearly I get 0. If I plug in 1, 1 to the power of 4 is 1, 1 squared is 1, so 1 minus 18, negative 17. Since all of them are negative except 0, this is the absolute max, add 0, 0. This is the absolute mean, add negative 3, comma, negative 81. Find the absolute max and mean values of the function f on the given interval, where f of t is t times 4 minus t squared to the power of 1/2, the interval of negative 1. We want to discuss the function and the domain. So first, let's rewrite this as t times 4 minus t squared under the radical, so square root of 4 minus t squared, which makes f of t a function which is a product of t, a linear function, and square root of 4 minus t squared, a square root function. So it's a product of the two. As you know, a linear function or polynomial of degree 1 has no restriction. The domain is all real numbers. This one has a restriction. We're going to find it, which means it really follows the concept of square root of x. X must be larger than or equal to 0. So 4 minus t squared must be larger than or equal to 0. So when you want to find the domain for this function is the intersection of the two. This one has no limit, so this one is the limitation. So the answer is for that. That would be the intersection of them. So how do we find that? Well, we are going to factor this into 2 minus t and 2 plus t. When we set this equal to 0, we get positive and negative 2. Now, to understand where this function is positive, you go with a number line and use a sine graph. So we're going to use a sine graph, which consists of a number line from negative to positive infinity. At the bottom, we represent the independent variable x, t, whatever, this is t. And we put the numbers that we found here from smallest to largest. So from negative to positive infinity, and we put minus 2 and 2. At top, we put the function, in this case, this one. 4 minus t squared is 0 at negative 2, 0 at positive 2. We want to know which one gives us positive. We have, because of these two, we really cut this in 3 sub-intervals. From negative infinity to negative 2, from negative 2 to 2, from 2 to infinity. Therefore, we need to use TPs, short for test points. Obviously, in between, the easiest number would be 0. To the left of negative 2 would be negative 3. To the right of 2 would be 3. Now, when You look at the factored format, and each one has exponent odd. This one has exponent 1, this one has exponent 1. They will alternate. So if you evaluate one of them is good enough. So if I use 0 and I put it into this expression, I get positive 4. So if it's positive here, they will alternate otherwise. If you have any doubts, put negative 3. You get positive 9. This makes it negative. 4 minus 9 is negative 5. We just want the sign. We don't care it's negative 5 or negative 10,000. We just want the sign. So we go back and say, okay, we need this one to be greater than or equal to 0. That means in this vicinity from negative 2 to 2. Therefore, we write f, which is a product of a linear function and a square root function, is continuous on the interval of negative 2 to 2. And therefore, it's continuous in the given interval of minus 1 to 2 because the interval of negative 2 to 2 contains the given interval of negative 1 to 2. So we just proved actually it works. And therefore, we're going to move on with f prime of x, in this case, f prime of t, whatever the independent variable is. So erase my one. And to differentiate that, this is the f function. This is the g function. We use the product rule of f prime g plus g prime f. So f prime is simply 1 times the second piece. You can put it in this format or this format makes no difference. We can go with that format for the sake of, differentiation. Ultimately, we have to put it back. So having said that, now we need g prime. What is g prime? If you look at this one, this uses the extended power rule, 1/2 times the same thing to the power of negative 1/2 because 1/2 minus 1 is negative 1/2. And by the chain rule, the derivative of the inside is negative 2t. And finally, this is g prime, we need f times t. So I'm going to write at top of it, this is f prime, this is g, this entire thing is g prime, and t is it. That's it. So f prime g plus g prime. Now we are going to rewrite this and simplify it. Number one, notice that this 2 cancels out this one and changes it to minus t. Number two, this we are going to change it to a square root of 4 minus t squared. When we go here, we have a fraction bar. At top, we have 1 minus t and t, in other words, minus t squared. At the bottom, this has exponent negative 1/2, goes down, becomes positive 1/2 and a square root. This is elementary algebra. I hope nobody has any problem with that. So because we want to find where f prime is 0 or doesn't exist, we have to combine them. How do we do that? LCD. LCD is square root of 4 minus t squared. So how do I deal with this piece? Very simple. I put a fraction bar. I put square root of 4 minus t squared at the bottom. And I also multiply this one by the square root of 4 minus t squared. In other words, I raise it by that factor. So now we have a common denominator of square root of 4 minus t squared. What do we have when we multiply these two? It just comes out as 4 minus t squared, and this one remains. And minus t squared, these two add up to minus 2t squared. So f prime of t is 4 minus 2t squared over the square root of 4 minus t squared. Pretty simple. So we have f prime of t. F prime is 0. A fraction is 0 if the numerator is 0. So 4 minus 2t squared is 0. 4 equals 2t squared. T squared equals 2. T is plus minus square root of 2. F prime does not exist. The denominator is square root of 4 minus t squared is 0. Square root of 4 minus t squared is 0 if 4 minus t squared is 0. T squared equals 4 or 4 equals t squared. That means t is plus minus 2. So we have 4 numbers to deal with. Let's look at each case. And bear in mind, again, reminding you, square root of 2 is about 1.41. So is the square root of 2 in between? Yes. What about negative square root of 2? No. What about negative 2? No. What about 2? 2 is one of the endpoints. So we can only use 2 and square root of. Therefore, we write the function and we evaluate it at the 2 endpoints and square root of 2. What is the function? The function f of t is t squared of 4 minus t squared, which means for this one, replace the t with negative 1. As you see, negative 1 squared is positive 1. 4 minus that is positive 3. This makes it minus square root of 3. Let's plug in square root of 2. So it's square root of 2, square root of 4 minus square root of 2 quantity squared, which is 2. And 4 minus that is 2. So it's square root of 2 times square root of 2, or simply 2. Plug in 2. 2 square root of 4 minus negative 2 quantity squared, which is positive 4. They cancel each other. They give us 0. The final answer is 0. So the absolute maximum is 2 at this pair, square root of 2 comma 2. Absolute minimum is, this is the only negative number, minus square root of 3 at this pair, negative 1 comma negative square root of 3. So to recap, before we differentiate this, we have to justify the domain, and we went through the sign graph to find the domain. And then we differentiated using the product rule, and f prime is 0 when the top is 0, doesn't exist when the bottom is 0. You check to see which ones are in the given interval, evaluate the function at those points, including the end points, and make a decision. Find the absolute max and minimum value for this case, where f of x is x to the power of 2/3 and the interval is negative 2 to 3. First, what type of function is that? This is cube root of x being raised to the power of 2, or cube root of x squared, if you will. I want to remind you a basic cube root looks like this, and domain is all real numbers. What happens when we raise it to the power of 2? Well, the positive portion becomes larger. The negative portion flips over and becomes larger in that sense. So what is the effect? There is no effect on the domain. The domain remains as all real numbers. Therefore, we're going to write f is a cube root function. It's continuous from negative to positive infinity, and therefore it's continuous in the given interval of -2 to 3. And we're going to move on with the process. Step 1, find f prime of x. To do so, we are going to go with this one, and I'm going to erase my work. So this is 2/3 x to the power of 2/3 minus 1, which makes it -1/3. To make some sense out of this, in order to find f prime equals 0 doesn't exist, we do rewrite it as 2 over 3 cube root of x. F prime is 0. That means the numerator must be 0. Since the numerator is a number, it can never be 0. So there is no solution, none, or an empty set. Normally, in an we would represent this with 5. Remember that. That means the same thing. F prime doesn't exist. The denominator must be 0, and the denominator is 0 when x is 0. Is 0 in between? Yes. Therefore, we can use 0 to evaluate. So we're going to evaluate the original function at the two endpoints as well as 0. The function f of x is x to the power of 2/3 or cube root of x squared. So when we plug in, I hope you see that if I put -2 squared, I get +4. Cube root of 4. This is an exact answer. This is an approximation. 1.5874. If I put 0 here, I hope you see that you get cube root of 0, which is 0. If I put 3 here, I get 9. So I get 3 to the power of 2/3, but it's better to go with that one. Cube root of 9. And you can clearly see this is larger than that, or roughly 2.08008. That indicates the absolute maximum is cube root of 9 at 3 comma cube root of 9. Absolute minimum is 0 at 0, 0. That's how we do the writing, everybody.